Chào các bạn và em. Hôm nay mình sẽ học chương 6 bài 2 Verifying Trig Identity. Câu hỏi của bài này là tôi phải dùng Fundamental Identity để verify Trig Identity làm sao? Đây là thầy Đôn. Done.
Alright, so we are now going to start, and we are working on 6.2. It's pretty much the same thing as 6.1, where we have to use trig identities to basically simplify. But in this section, we're actually going to be given the trig identities that we need to simplify down to. So let's go ahead and first copy down the highlighted portions. And these are basically the steps in order to verify a trig identity. So again, copy down the highlighted portions as I read through them. So one, we're going to work with only one side of the equation at a time. There's going to be two sides, obviously, and we'll work with a more complicated one. So for number 2, you're going to look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. That one's the most important one. Please make sure you know how to do that. 3, you're going to look for opportunities to use fundamental identities. So we want to use all those trig identities that we've been working with the past 2 days. 4, when the preceding guidelines do not help, try converting all terms to sines and cosines. Sine and cosine really kind of break it down to the simplest forms, and they always work out a lot nicer. And then 5, just try something. So you might have seen yesterday that you had difficulty and it didn't come out correctly. You actually probably were on the correct route, or at least we're halfway there. It's just got a little difficult. But what we're going to see today is that you do have to make mistakes in order to get there. All right? We're going to go ahead and then start with example 1, where we need to verify a trig identity. So in this one, we're going to go ahead and do 1 minus sine squared theta over 1 minus cosine theta. And then we need to verify that it's the same exact thing as negative cosine theta. So what I want to do here is look only on the left-hand side, because this is the more complicated expression. Over here, we only have negative cosine theta, and it would be more difficult to convert this guy into all of these. So let's look over here and figure out what could be our first step. If you remember from yesterday's problems, there were a lot of equations and expressions where we had 1 minus cosine theta, 1 plus cosine theta, something similar to that, that basically suggested that you should be using the Pythagorean identity of sine squared theta plus cosine squared theta equals 1. And the reason we would do that is because if I were to simplify this so that sine squared is by itself, it's the same exact thing as 1 minus cosine squared theta. 1 minus cosine squared theta, of course, factors down into 2 different factors. We have 1 minus cosine theta and 1 plus cosine theta. So in that case, we're going to take advantage of that and use 1 plus cosine theta to simplify this over here so that I can get just sine squared theta on the bottom. In other words, a monomial denominator. All right, so let's go ahead and show that step. Sine squared theta, 1 minus cosine theta. We're going to multiply this on top and bottom by 1 plus cosine theta. And again, it's going to try to prove that somehow it's equal to negative cosine theta. I'm going to go ahead and distribute this. So 1 minus sine squared theta. Actually, for this one, I'll kind of show you ahead of time. We're not going to distribute it just because there will be something that cancels out. And then we have 1 minus cosine squared theta. So rather than writing it as 1 minus cosine squared theta, we know through our identities that 1 minus cosine squared theta is the same thing as sine squared theta. So here I have 1 minus sine squared theta times 1 plus cosine theta all over sine squared theta. Because this is all being multiplied together, I can go ahead and cancel out these two, leaving me with 1 minus parentheses 1 plus cosine theta. Parentheses are important here because that negative needs to be distributed to both terms. In this case, I'm going to get 1 minus 1 minus cosine theta. Obviously, 1 minus 1 are going to cancel out, leaving me with negative cosine theta, which is exactly the trig identity that I wanted by the end of all this. All right? So, in a way, this section might be a little easier for some of you because we have exactly our end goal, so we know what we're working towards. All right? We're going to go ahead and do one more example just to get a little bit of extra practice. So with example 2, we're still going to verify. This time we're going to have secant squared theta minus 1 over secant theta, or secant squared theta, and it's going to be equal to sine squared theta. Now in this case, we already have a monomial denominator. Now be careful here. Some of you might say, wait, can't we just cross multiply and get the secant squared theta over here? We're trying to verify trig identities, so we're not trying to actually move anything over to the other side. We're not trying to solve an equation. We're trying to prove that all of this can be changed and basically manipulated so that it looks exactly like this, all right? So we're not using, both sides and trying to solve an equation for theta. All right, with that in mind, we do know that one of our Pythagorean identities suggests that secant squared theta is equal to tan squared theta plus 1, which means I can manipulate this one so that I get secant squared theta minus 1. I'm going to do that by subtracting 1 to both sides. So I get secant squared theta minus 1 is equal to tan squared theta. With that, I'm going to go ahead and substitute in tan squared theta into the numerator so that I can simplify this a little more. Tan squared theta over secant squared theta is equal to sine squared theta. Over here, at this point, they're already monomials, so the next best thing to do would probably be converting them into sine and cosines. So tangent squared would be sine squared over cosine squared. Secant would be 1 over cosine squared. Now I'm continuing to manipulate this one. Dividing by a fraction means that I'm going to multiply by its reciprocal. And hopefully as I'm writing this, you're kind of seeing what's going to happen. The cosine squared thetas will cancel each other out, leaving me with just sine squared theta and exactly the result that I wanted up here. All right? So those are 2 examples of how we are going to verify trig identities. We're going to do a couple examples in class tomorrow. So as always, rewind and replay as needed. Otherwise, come ready with your questions and have a good day, you guys.
Ciao bạn.